So we are becoming more and more familiar with blood and blood typing and the things that we can do with a blood sample. And in the previous video, we left off at this concept of hemoglobin. And we said hemoglobin is an iron carrier, and if you do not produce enough hemoglobin, you will not move enough iron throughout your body, and in turn will not be able to transport oxygen throughout your body. And we said that we're going to play off of this heme group, we're going to play off of this iron, and we're going to play off of some of these charges that this protein molecule could do for us in order to detect if something truly is a blood sample or not. So the very first test that I want to introduce to you on blood identification would be something called the Kastle Meyer test. All right, so the Kastle Meyer test is actually stuff that you've already used in our program before, over and over and over and over. And the Kastle Meyer test is basically phenolphthalein. Down here at the very bottom, you see it right there. Phenolphthalein, there you go. So phenolphthalein is going to be a molecule that we can use, put it in solution, and apply it to a blood sample or something that we think is possible blood, and it would have a certain reaction to the blood sample, and it will turn that characteristic pink for you. All right, so how is this test done? Okay, so if we look on the slide, Kastle Meyer, it's based off of hemoglobin, like I told you it was going to be, and it will confirm if the sample is blood or not. So the way that we do it, it's a very simple test. We take a cotton swab. This can be something very similar to a Q-tip, right? And we're going to dip it in ethanol, and then we're going to place it on what we think is the blood sample, and we're going to give it a good rub. So we want some of that sample to transfer onto the cotton swab that I have now wetted with alcohol. Once I think that I have some of that sample transferred onto the Q-tip, I'm then going to add a couple of drops of what we're going to call Kastle Meyer reagent. So Kastle Meyer reagent is a very simple reagent to make, and the recipe is down here for you. 0.1 gram of phenolphthalein, 25% of sodium hydroxide, 0.1 gram of mossy zinc, and you're going to boil it until a pale yellow color is formed. If you boil it and some of that volume goes away, you want to add extra water to maintain the total volume here. That way it can stay consistent. Then you're going to cool it. Then you're going to dilute it. And then you're going to dilute it with 70% ethanol. So that is your Kastle Meyer reagent recipe. Now, do I want you to memorize this recipe? The answer is no. The Kastle Meyer reagent is going to be provided to you if you have to use it in the lab, or you can quickly look these recipes up in a laboratory environment if you need to know how to make it. But there's nothing special here. That's the reason that I'm sharing this recipe with you. It's a little bit of phenolphthalein, it's a little bit of base, and it's a little bit of zinc. And I should boil this stuff down until it goes yellow in color, and then I'm going to dilute it to the line with ethanol. So I'm going to add a couple of drops of that Kastle Meyer reagent to my Q-tip. Nothing will probably change at this point. If your Kastle Meyer is already pink, though, that means that this is a bad reagent. It cannot be pink in this step. That's why it says pale yellow. Okay? So I take the Q-tip, I dab it on the blood sample, I transfer some of the blood onto the Q-tip, I add a couple of drops of Kastle Meyer reagent on top of that, and then finally I'll add a 3% hydrogen peroxide. This is basically hydrogen peroxide that you buy into the store. There's no difference here. And by adding the peroxide, if blood is present, we will get pink for a positive test. That's the color that I'm looking for, just like in a titration. That's where you've used phenolphthalein over and over before, right? We go from colorless to pink, and the same thing is going to happen here. Now the problem is that this is somewhat of a timed reaction. You don't want to wait forever before you look at this Q-tip to see if it will turn pink, because more than likely it will eventually go pink after 30 seconds. So 30 seconds or less is going to be the key here for the Kastle Meyer reagent. A false positive can happen if you wait longer than 30 seconds and it turns pink and you record that as a positive blood sample. No, it's not. It's got to turn pink before 30 seconds is up. So that's the phenolphthalein reaction with blood, or what we would call the Kastle Meyer test. A very simple test, a very qualitative test that works pretty well in a laboratory. And some people actually use Q-tips. Some people will use what you're seeing here onto the right-hand side of their screen, a filter paper. They've just taken a piece of filter paper and dabbed it and rubbed it onto the possible blood sample. And then that will transfer over, and they can add the reagent to that if they wish. The chemistry of the Kastle Meyer test, because let's face it, that's kind of why we're here. Why does this thing work the way that it does? Well, phenolphthalein is boiled. So what you're seeing here is phenolphthalein, and here's the molecule of phenolphthalein, right? And in our recipe, we used NaOH, but you could also use KOH. It's the same thing. It's still a base. And that base is going to add to phenolphthalein. And what you're seeing is kind of a rearrangement here, right? So it takes this phenolphthalein structure. Notice that it breaks these bonds, and it gets rid of that hydrogen to form a double bond, and it does a diene kind of in place here in the ring structure. And then that conjugates the system, so single, double, and we can go more inward into the molecule. This, what was a 5-membered ring, now almost in a way gets ready to turn into a 6-membered ring. This bond breaks with that carbon. You can see it dislodging itself from there, and it's getting ready to open itself up. This ring on this side does not change. It's pretty much the same before and after. And over here on this side, to the right-hand side, that ring also pretty much stays the same, except it removes the H's from here. Think about it. This is a base. That base is going to look at these acidic alcohol groups, and it can rip those protons off of there, right? Pure acid-base chemistry at play here. So that's why we see the H removal at this point. That's also why we see the H removal at that point. Those electrons between the O and the H bond, once the H gets ripped off, those electrons move inward to those oxygens, and then if they can, they will share throughout the molecule. And we call that delocalization. If you've not learned about that in organic yet, you will shortly. So this is what gives this thing a pink color. So a normal titration, this is how it works, right? You have an acidic solution, you add some phenolphthalein, and it's colorless. It starts off like this. As you add base, the acid is neutralizing that base. As you add more base, sooner or later, the base will overtake the amount of acid, and we get basic conditions. And this is representative of the KOH or the NaOH. This is a base. And that goes pink. This is why that molecule turns pink. It's a rearrangement. It's a conjugation of the phenolphthalein. And that's why we get that color choice. All right, so in addition to that, though, the Kastle Meyer is more than just that. That's only one piece. We had to add zincy moss, right? Or zinc moss. So here is the zinc that we're going to put into the recipe. And then we're going to continue to heat it. So it goes to this intermediate type of stage, and then it goes back to this phenolphthalein here, right here. So if we take a look at what's going on, well, this zinc is taking the structure, and look, it's still negative here on this end, and then here it's still negative on that end. These electrons have just basically moved into the ring to conjugate this system is what's happened. This ring is still a ring, no big deal. And this C double bond OO with a minus out here is still C double bond OO. Not too much has changed. But because that double bond has now been moved inside of the ring through delocalization with the help of zinc, we now get a colorless reaction again. But we say no color, but this is really, maybe to us, will look very yellowish, pale yellow urine color. This is really the Kastle Meyer reagent that we're looking at right there. Okay? So this is what's in our dropper bottles. This is what we're going to add to the Q-tip or to that piece of filter paper. And if it goes back pink, if it goes back this way and we get this pink color, then that is a sign that blood is present. And that reaction is catalyzed by hemoglobin. That's all that reaction is basically doing. So in the presence of the heme group, and with the help of peroxide, which is right here, right? That's peroxide. H2O2 rewritten is HOOH. In the presence of the heme group and a little bit of peroxide, we get the reversion of this molecule, and we get this pink color that happens from our indicator. That heme releases electrons. Those electrons go back and saturate that molecule a little bit, and it replenishes these that happen between the carbon and the double bond oxygen. And it makes the pink phenolphthalein again. All right, so that's the story with the Kastle Meyer reagent. If you want to know what pink is pink, then basically here's an option for that, right? So over on the left-hand side of the screen, you see a positive, a true positive color. That is bright fuchsia pink, people, right? If this was a titration, we would say you over-titrated that phenolphthalein at this point. But this is the pink that you might see. A baby pink might start off too in the beginning, but this bright fuchsia pink is what we're all after. The negative test, of course, there's nothing on it. Your Kastle Meyer reagent might be a little yellowish, but it will not turn pink onto the Q-tip. Okay, so that's the story with the Kastle Meyer test. That's only one test, though, that we can do on a possible blood sample to figure out if it really is blood or not. So in the upcoming videos, we'll talk about some of the other options that we might, as a forensic chemist or a forensic technician, to be able to use to detect the presence of blood and to see if maybe a stain is actually blood or not.